Today I'm very enthusiastic to speak to you about canal preparation. And obviously canal preparation is just one of the steps that comprises start to finish endodontics. As you can see here in the breakout, there's different ways we can prepare canals. In another segment, I spoke about ProTaper and explained how that system can be used in continuous rotation to prepare canals that provide sufficient space and deep shape so that we can exchange irrigants and fill root canal systems. Today, I'm very happy to talk to you about the new WaveOne system. Let's get started. Well, as I have just mentioned, there are many different ways that have been utilized over time to prepare canals, but regardless of the method selected, we need to keep in mind the anatomy of the human teeth. And in this Frank Paquet micro CT scan, it is a little bit sobering what the assignment is. But the main thing to emphasize is there aren't a set of files available in the world today that can clean a root canal system. What we need to think about is using instruments that can follow a glide path that can shape secured canals. And if we shape the main body of the canal from orifice to terminus, then if we have sufficient shape, we can get our reagents in here in sufficient volume so that they can circulate, penetrate, and exchange into the deep lateral anatomy. There's been a lot of emphasis recently on reciprocation. And of course, if we go back just a little bit in time, we would want to point out that most of the systems available today, there's over 30 file systems that are used to prepare canals or shape canals, turn in continuous rotation. So that has been pretty much the paradigm set from the time Rotary first emerged on the market in the early 90s. However, there's an old expression, everything old is new again. And reciprocation is not new, it simply has been reinvented. Let me explain. In 1958, the French dentist Blanc invented the world's first reciprocating motor and handpiece. And what I need to mention is others followed. But what was important about the early systems, and even the ones that are used today up until the top file I will speak about just in a moment, is everything turned in equal bidirectional movements. Let me explain. Originally, back in the late 50s, as we saw different systems come to market, Hess talked about the anatomy. So some of the clinicians, because of this anatomy, wanted to invent instruments that could work more safely, especially in curved canals. So one of the things that we noticed in rotation as the decade proceeded from the early 90s and into the 21st century is we noticed that there was a lot of broken instruments. And so of course we needed to look at ways to mitigate broken instruments. And so there was a lot of emphasis on good access, and of course tremendous emphasis in recent years on glide path management. But obviously when you rotate an instrument continuously around a canal curvature, there is going to be potential for torque failures. Additionally, when an instrument moves around a curvature and it's spinning, we have to think about cyclic fatigue. So torque and cyclic fatigue are issues in continuous rotation. Fortunately, most of this can be mitigated if we choose the correct instrument set that can mitigate some of this binding where the metal instrument is engaging or over-engaging dentin. Many of you have heard me talk about ProTaper. It's the only file system in the world today that spins continuously, that has progressively increasing and decreasing percentage tapers on a single instrument. This has gone a long way to eliminate torque and cyclic fatigue issues. Still, some colleagues are left with these issues, and certainly a lot of the file systems that are available today absolutely have to be considered as risk-taking to use them because of the way of the file's designed, its cross-section, and how they're leading typically most instruments with their smaller, more vulnerable, and less efficient terminal extent of the file. That's what's leading in the canal. So today I'm going to talk about reciprocation because going back to the past, all the angles, forward angle and the reverse angle, were equal. So if a file moved forward 90 degrees clockwise, then it would move 90 degrees counterclockwise. So we call that equal bidirectional angles. Well, as time went on, other motors and handpieces came to market, and certainly in today's world, Cybron Endo has the M4, and if you go to Essential Dental Systems in Manhattan, they have an instrument or a device and a handpiece and a motor that turns instruments at 30 degrees. And finally, Dan Fisher's company, Ultradent in Utah, they have a reciprocating handpiece that drives files. But what all these more modern systems have in common is they turn in equal bidirectional angles where the angle is 30 degrees forward and 30 degrees in the reverse. We'll look at this a little bit later and talk about how this limits the efficiency and the effectiveness of those instruments. So when we look at continuous rotation versus reciprocation, there's quite a bit we need to understand, and Dentsply internationally launched WaveOne files through their MyFair and Tulsa divisions. Alternatively, another division of Dentsply, VDW out of Munich, Germany, they launched something similar called Reciproc. But what WaveOne and Reciproc have in common is they utilize unequal bidirectional angles. So you can see that this system supplies 3 files, and we'll talk more about the geometries of the files in just a moment. But the point to make quickly here is that 3 files are available in this single file technique because we encounter various anatomical forms in daily practice. So certainly we need some variation between instruments and among instruments to address a diversified array of anatomy that's encountered in everyday practice. So Reciproc has 3 files and WaveOne talks about 3 files. As a co-inventor of WaveOne, I'm going to speak about WaveOne because that's the file system that I'm most familiar with. So let's get started. The most important thing to say here is we have 3 instruments, but we're only going to use 1, and WaveOne is a single file technique. Now, how can we have a single file technique? You're probably wondering, how can we take a canal that has a secured glide path and transition it from a loose tin to a final shape with one single instrument? And of course, the secret to this single file technique is the instruments have an advanced design. We're working with super metals, which will be explained shortly. And finally, we're not using equal bidirectional movements. We have a unique movement with WaveOne that allows the instrument to more readily advance and to be more efficient and safe in its cutting action. All this will be looked at just in a moment. So let's look at the design of the file. And if you look quickly at the file, the first thing you might notice if you look more towards the shank side blades is there's a reversed helix. These instruments turn or engage and cut dentin in a counterclockwise direction. Well, there's other things that make the design quite unique. And borrowing from the success of ProTaper, which is the #1 continuous rotation file in the world, its success story had to do with its design. And what you can see is the 2508 is a 25 at the tip. There's an 8% taper, but the 8% taper is confined between D1, D2, and D3. We have regressive tapers behind the fixed taper, and the point of having regressive tapers is you have a more flexible instrument and you don't needlessly over-enlarge the coronal 2/3 of the canal where we can promote a strip perf or weaken a root and predispose it to longitudinal fracture. So by decreasing the percentage taper, we can have an instrument then that is more flexible and is more conservative and will maximize remaining dentin. Another unique design feature, taken from the ProTaper family of instruments, is the convex triangular cross-section. And this particular cross-section is only between D9 and D16. So this convex triangular cross-section is very efficient, but we can modify that convex triangular cross-section and make 3 concavities in each convex side, and we can put this between D1 and D8. When you put this cross-section on that aspect of the active portion of the file, it allows the file to more readily progress. It helps the instrument be more efficient. And of course, if an instrument can engage and cut safely, then we have less torque, and that's going to be a safe feature for the file. The other things I'd like to point out about the design, and I've mentioned the reversed helix again, but I'll now want to talk about the changing helical angle. Most modern file systems today have changing helical angles over the active portion, and what this does is it allows the debris to auger up the cutting flutes more effectively, it allows the instrument not to over-engage, and it distributes the workload out more effectively. Changing the pitch, that just means simply the distance between each active portion. It actually is changing over the length of the file to also help with the augering of debris and moving the debris in a coronal direction. And this is very, very important, especially when we talk about reciprocation, because in continuous rotation, we very effectively move debris up the blades where it can be spiraled up into the pulp chamber and liberated from the root canal space. So, when we talk about reciprocation, when we have equal bidirectional movements, we don't get augering nearly as effective as if we have unequal bidirectional movements. The second feature that led to the ability to have a single file technique was metallurgy. And obviously, at some point, companies have looked at the helical angle, the cutting angle, the rake angle, the tip geometries, the taper of the instrument. And when you look at all these things, if it could be done, it has been done. And so at some point, manufacturers begin to look into other ways to improve manufacturing files. And one thing that the whole world has now discovered is metal alloys off the original niti. And of course, the phase transitions that you can talk about are martensite and austenite. And if you think about the game of tennis, when a tennis player strikes the ball, they want to hit the ball on the racket in what's called the sweet spot. This gives them maximum velocity and solid control of the ball. In metallurgy, there is a sweet spot between these two phase transitions. And through heating the instruments up and then allowing them to cool post-machining and heating them up and letting them cool, you'll absolutely be able to identify the sweet spot between these two eutectic phase transitions. And what you end up with is a supermetal called M-wire. So M-wire reduces cyclic fatigue up to 400%. And when that article by Sergio Cutler was reported in the Journal of Endodontics, it caused a staggering realization that metallurgy is one of the future ways to improve the safety of canal preparation. Well, another thing is, if you reduce cyclic fatigue, you also are going to improve on broken instruments. Certainly, file separation is a major upset for any practicing dentist. So metallurgy is the second thing. So we have a great design with WaveOne. We have metallurgy, M-wire, and finally we have a dedicated motor. And when it's turned on, it's dedicated to drive WaveOne files. And the movement is very, very particular. And remember, we have a reversed helix, so the engaging angle is 150 degrees counterclockwise. The disengaging angle is 30 degrees. And if you begin to look at this on an animation, look at the rubber stop on the file and watch the unidirectional black line to help you better understand in slow motion how this instrument's working. But there's the 150 engaging, and then a little short 30-degree disengagement. If you subtract 30 from 150, it leaves you with a difference of 120. So 3 cutting cycles means we're going to move the instrument 360 degrees after those 3 cutting cycles. And if we're spinning circles and strategically always after 3 cutting cycles making 1 revolution, then we're going to move debris up the blades more effectively, and that means less lateral blocks, less apical blocks, and this all promotes the biological objectives for canal preparation. Okay, let's come back to the 3 instruments and look at them a little closer. The yellow band on the handle is what's called the small WaveOne, and it has a tip diameter of 21, and it has a continuous taper over the entire active portion of 6%. The red banded instrument is a primary 2508, and its tip diameter then is 25. Its percentage taper is 8%, but like we saw previously, the 8% fixed taper is only between D1 and D3. And it has regressive tapers from D4 to D16. And the large WaveOne is a 4008. That means the tip diameter is 0.4 of a millimeter, and the taper again is 8%, and again the taper is confined between D1 and D3. From D4 to D16 it has regressive tapers, and again the primary and large WaveOne files have this feature, and that is to maximize remaining dentin and improve flexibility on the bigger instruments. So now you know a little bit about the reverse helix, the cross sections, the tip diameters, and the tapers. I think we have enough information now that we could put these things into use and learn how to use them. So what is the protocol? With any endodontic procedure, I want to emphasize the importance of complete access. Access cavities need to be cut with the thought in mind that we need to find all the orifices. In other segments, I've talked about 17 tricks to finding canals that are calcified, aberrant, or in the retreatment situation that were previously missed. So access is still critical, and of course we finish our access cavity by flaring, flattening, and finishing those internal axial walls. Well, glide path management is also part of the protocol, and WaveOne instruments can cut and progress through any part of a canal that has been first secured with a loose tin file. So when we talk about glide path management, we want to talk about securing canals. When we secure canals and we use some small-sized hand instruments, we want to create a smooth, reproducible glide path. And when we have a loose tin file in any region of the canal, then you can employ the first primary 2508 file. When I say first, we always, I repeat, we always begin shaping procedures in the WaveOne family with the primary 2508 instrument. I will explain when the other instruments are used in just a few minutes. Finally, later in this show, we'll look at the finishing criteria and how you can determine with 100% confidence, am I done? Have I finished the shape? Is the preparation conducive for disinfection procedures? Is the preparation conducive for filling root canal systems? So we'll look at the work of the primary 2508 and the finishing criteria in just a few minutes. Okay, so let's look at a patient, and we'll take the things we've just learned and discovered, and let's see how this might work. Now I want to repeat again. I know you've heard me talking, but I'm going to reinforce it because it probably hasn't completely sunk in. This is a single file, single use technique in about 90% of all cases. Let me explain. There was a team of clinicians that built the WaveOne file. Specifically, there were 6 of us spread across the planet. It took 4 years to develop the WaveOne files from concept to validation. Over those 4 years, 6 clinicians did many thousands of cases. What we found out was that about 88% of the time, we only needed one single instrument to cut the shapes on the teeth that were referred in for endodontic therapy. So I want to repeat that with some experience, this is an easy technique to learn, and you will be using one file most of the time. Now, when you're using one file most of the time, and I might add to do a single canal and a central incisor as an example, or you might be doing a molar that has 3 or 4 systems. You're still using a single file. So because a single file is called upon to do an enormous amount of work, you should be appreciative of the SEMs of those instruments after they've been used on about 3, 4, 5, 6 canals. The edges begin to roll over a little bit. We start to see blunting on the cutting edges. That means the instrument is starting to dull, and this means its performance is compromised. So you must think about the good news is you are never going to have greater simplicity in preparing canals than using a single file. And please embrace that concept and also understand that we can't then use the same instrument over and over again on multiple teeth, because you're going to promote or invite broken instruments. You're going to have to use more pressure because the instrument's dull and it's not going to be working like it was designed to work. So looking at this first molar with the crown on the tooth, I'm going to take the crown off with the metal lift. That's a device I've talked about in other sections that you can learn about if you're interested, because by removing crowns, we've made the tooth shorter. And oftentimes, if you can shorten the working distance, you can move from a 31 millimeter instrument to a 25 or ideally a 21. The closer we can get our fingers to the tip of the instrument, the more control we're going to have. Again, begin to appreciate the furcal side concavity. You can see it's quite a strong one. You can see there's mesial fluting on the mesial root. And look at those canals moving down through the root centrally. And you can see how the canals, as we ascend coronally, bend abruptly into the pulp chamber. So let's get started. As usual, you need a diagnostic length. So this is not the truth. You will superimpose a pre-curved tin file over a well-angulated film, and that will be roughly your diagnostic working length. Now, if you're going to take the crown off, like I just mentioned, you'll have to anticipate that you would want to subtract another couple millimeters roughly off of this anticipated working length when the crown is removed. So with the crown off and the tooth isolated, immediately what I would want to do in this vital case is place a viscous chelator, like RC Prep, ProLube, or Glide. A viscous chelator is going to give us a superior lubrication. It's going to be able to break down collagenous tissue, and we want to prevent collagen from readhering to itself. So typically when we pull out a file, when we've been using a bath of, like, say, sodium hypochlorite in a vital case, that collagenous tissue will readhere to itself, and we do not have left a preferable pilot hole. So a viscous chelator is not only a lubricant, but it prevents the readherence of collagenous tissue. And finally, the debris that the file's making during use, it's holding that debris that's generated more effective in suspension relative to an aqueous solution like sodium hypochlorite. So I'm always using a viscous chelator to get a glide path going. And notice how the tin file is now traveling in progressively longer strokes, easily, repeatedly, and reproducibly. Push the stop down, remove the instrument, and this is the depth of the secured portion of the canal. I really want you to lock into the concept secured canal. Now, transfer that length to your first mechanical instrument, the primary 2508 WaveOne file. That means that by moving the stop down on the mechanical shaping file, this instrument stays inside the secured zone. It means it never goes more apical than we have had complete confidence the tin file can work through. So the tin file is working through the coronal 2/3 of the canal. It's loose, so the loose tin is all the space that's necessary in order for this particular file, with its design, with its unique movement and its metallurgy, to move through the glide path. Let's see how that would work. When we shape canals, we need to remove the viscous chelator, so let's irrigate with 6% solution of sodium hypochlorite. Having just finished the ML, let's watch the MB. Notice how the instrument will run. Let it run and progress, typically 3 or 4 millimeters at a time, through the secured part of the canal. If the instrument doesn't move and ceases to progress, remove the instrument, inspect the flutes, clean the blades, irrigate, recapitulate with your tin file, and re-irrigate to ensure the glide path is still present. Put the same file back in and let it run, and you will let it run until the rubber stop meets the chosen or selected reference point. Then irrigate, recapitulate with the tin file, and re-irrigate. Now that you've got a coronally pre-enlarged canal, we can pre-curve the tin file. It can be passed through the pre-enlarged canal. The instrument will arrive in the curvature curved. Using little rocking back and forth reciprocating motions on the handle, begin to work the instrument through the viscous chelator that gives us lubrication, emulsification, and keeps the debris in flotation, and begin to work that file deeper and around the curve. When you get about a stop or two short, there should be no more reciprocation. It's a linear slip and slide, and try to slide and glide to the working length. So once you have the tin file at the working length, I want you to go a little further vertically, and I want you to clear the foramen of any residual tissue or mud that might have been accumulating. Patency instruments are absolutely critical, and we can't shape canals that don't have a reproducible glide path. So here's patency clinically. It's deliberate, it's done intentionally, and it's done repeatedly until the instrument is loose. Well, you have a known working length, you have a patent canal, you need to ask yourself, do I have a glide path? So by pulling the instrument back a stop or two, slide it back to length, now pull it back 3 or 4 stops, see if you can slip and slide back to length. Now pull the instrument back 4 or 5 stops. If you can slip and slide and glide easily and repeatedly through a smooth, reproducible glide path, WaveOne primary will easily carve that shape and to length. So we irrigated, kicked out the viscous chelator, and with a suspension of 6% sodium hypochlorite, let the instrument run. Let it run 3-4 millimeters. Lift it up. That'll encourage the debris to auger up the blades, and then let the instrument move right in a little bit deeper, and typically it will run or progress 3-4 millimeters at a time. And clinically, you can see how that rubber stop is coming right down in approximation to the selected reference point. Very controlled and very safe. Notice all the debris that was on the blades of the file, but notice all the residual debris that's inside the pulp chamber. So we must irrigate. The endoactivator is a wonderful device because it has a polymer tip that can be placed below the orifice, and it can move debris and pulp tissue into suspension so it can be subsequently irrigated out of the canal. Well, it's now time to gauge the foramen. And certainly if we used a 2508 primary WaveOne file, then you're really wanting to know how big is the terminus of this shaped canal. And the terminus of the canal can be judged very nicely by gauging. Gauging is a term I began using back in the late 70s. It's a mechanical or machining term, and simply using a 2502 ISO hand file, okay, it's just got a 2% taper, so it's going to easily move through an 8% taper. Notice how loose this instrument is over its cutting blades. The only thing in common between the 2508 and a 2502 is they're both 1/4 of a millimeter at the tip, so you're putting the hand file in, sliding it to length, and the question you want to know, is the instrument snug at length? If it's snug at length, you're done. The shape is complete. If the instrument is noted to be loose at length, it simply means the foramen is bigger than a 25. We'll talk about what to do in that instance in just a moment. So if the instrument is snug at length, we have confirmed the shape, and now we need to really re-emphasize a device like the endoactivator as an example, where I showed it just a few moments ago. It can be placed in this shaped canal, and that polymer tip can mechanically hit the walls. That's a good thing. The solution is activated and it's energized, and through instability of bubbles that are forming and they're growing in size, they implode because of heat and pressure. The bubbles are unstable. And when a bubble bursts or implodes, it sends out 40,000 shock waves. So the endoactivator works by bombardment, and it moves solutions into the deep lateral anatomy. So if we got the shape, I'm only emphasizing we can gauge the foramen, and if the shape is confirmed, we would then disinfect prior to fitting cones. So certainly, you could fill this root canal space with a number of different methods, and we'll be talking about these in other shows. But in this particular instance, I fit a matching WaveOne master cone. Notice the red heads on the pink gutta percha cones, and they're slid to length. They would be confirmed radiographically at the correct length, and then we would use a Schilder type technique, warm gutta percha with vertical condensation, and thermal soften these cones, and through heat and pressure carry a wave of warm rubber deep into the apical 1/3 where we can cork or fill the root canal space. Well, it's pretty exciting to see the post-operative film. Notice the tooth has been provisionalized, but if you look at the mesial root first, you can see that there is a nice flowing shapes moving through curvatures. Notice the little recurvatures in the last 2, 3, 4 millimeters. It's really nice. It's very reassuring to notice that a single file or any series of files can actually follow the anatomy very carefully and not relocate the foramen, not transport the foramen, but leave it spatially where it was physiologically. It's just slightly enlarged. Notice the significant lateral canal crossing over the MB root, and then notice the mid-mesial. If you look deep in the last 2 or 3 millimeters, coming off of the more mesiolingual system, there's another system with its own separate portal of exit. Notice the distal root with its bifidity. This is the kind of endodontics that you want under the provisional crown that will be coming. And then finally, when we get these restored, you know you've protected the endodontics, and the occlusion's good, the margins are sealed, and the rest of the seal has now been affected. Predictably successful endodontics is the cornerstone of restorative and reconstructive dentistry. Well, we have 3 instruments. We always begin treatment with a primary 2508, and that always is inside a glide path that is confirmed to be a loose 10. So if the 2508 reaches length and the rubber stops on the reference point, simply pull the instrument out, irrigate, recapitulate with a tin file, and re-irrigate, and then ask your assistant, I wonder if the foramen is a 25. So she'll hand you a 2502 hand file, and again, to be redundant, notice that this instrument is just 2% tapered on the right. We have an 8% tapered instrument on the left, so the 2502 is going to be loose over length. The question is it snug at the full working length? If it is snug at length, then the shape is done, and you can turn your attention to disinfection and then obturation. If the 2508 will not progress, so you're letting it passively run, I mentioned it'll usually run 3-4 millimeters at a time. We know from our research that most canals that have a confirmed, smooth, and reproducible glide path can be shaped in less than 1 minute. So if an instrument doesn't progress, it probably means the tip diameter and or the taper is too big for the glide path. Now I know you're going to say, wait a minute, Cliff, I thought you mentioned that this would progress in any glide path that had a loose 10. That is almost always the case. But there will be some canals, because of curvature, because of the length of the system, because of the diameter of the system, where you might need to use the small WaveOne file, which is a 2106. So the small 2106 is considered a bridge file. Let me explain. In really long roots and really thin roots, and perhaps more abruptly curved canals, The 2106 is the bridge file that will get you all the way to length if you have a loose 10. So we use the bridge file when we can't carry the 2508 to length. The 2106 may be the only instrument used in the apical 1/3, and I'll say it again, especially in longer, more narrow, thinner roots with more abruptly curved canals. However, we have to make a decision that if we have a pretty bulky root, if it's not such a long one, if it's not such a narrow one, and the curvature isn't so great, we can use the 2106 as a bridge file so we can come right back in with the 2508, and that means it will now progress quite easily to length. Now, you're thinking, wait a minute, this simple single file technique that Cliff was just describing has now become a two-file technique. Well, I have good news. I already mentioned this, but perhaps you need to be encouraged again. Doing thousands of cases over 4 years, 6 clinicians found out that WaveOne is a single file technique in about 88% of all canals that were referred into those specialty practices, which means the two file technique then is probably 10, 12%. So this is still a very, very efficient and simple technique when you know how to use the files and appreciate how they're made, appreciate the metallurgy and the movement. Well, after the 2508 reaches length, again, we would gauge the 2502. Again, if the 2502 is snug at length, we're done. But you can imagine there are those cases out there where certainly the foramen is bigger than 1/4 of a millimeter, and if you pull out the 2508 WaveOne and you gauge with your 2502, if you discover that the 2502 is indeed loose at length, it simply means the foramen is bigger than a 25. Probably the foramen, you could argue, who knows how big it is exactly, but it's probably pretty close to a 30. And from 30 to 40, the difference is 10. 10 over 30 is 1/3. It's not such a big deal to bring a 4008 in behind a 2508. The reason I mention the percentage change is some colleagues are thinking there should have been a WaveOne file that had a tip diameter perhaps somewhere in between 25 and 40. And I just told you we don't need anything in between because it's only about a 33% percentage change at D0, the difference between the 2508 and the 4008. And the other thing that's encouraging is keep remembering this is a different paradigm. This is a different file design than you're accustomed to. This is metallurgy that you might not be aware of. And again, the movement is completely novel. We're using unequal bidirectional movements. When the 4008 is carried to length, simply remove the file, irrigate, recapitulate with the 10 file again. The 10 file moves residual debris into suspension so that when we re-irrigate, you can liberate that debris as well. Well, gauge with the 4002. The question always is, how big is the foramen? So if you come in with a 4002 and if it's snug at length, you're done. If the 4002 is loose at length, then there are other systems that can be used to treat these typically more straightforward canals. Let's keep it simple. Well, let me give you an example where you might use this 2106 as a bridge file. So if you're doing a mandibular incisor, there's two canals. They're very narrow roots, mesial to distal. And if there's a second system, we have to be very respectful of external fluting. So in this case, you might have taken a 2508 deep into the canals, but if they were a little bit reticent to move that 2508 into the apical third, if it doesn't want to easily go, don't push, just irrigate, recap, irrigate, make sure you got your glide path and come in right in with your 2106, and you will notice it will readily reach the working length. It would be your determination if that was as big as you chose to shape your apical 1/3, or if you wanted to return back to the 2508 to carve a little fuller shape that would have a little bigger terminal diameter. Well, you saw this particular case, And it's just another example where a single 2508 primary WaveOne file carved out 3 shapes in just a few minutes. And of course, some of these are quite large. And in this mandibular bicuspid, it's a fairly simple system, but it is quite large in its working width. And notice there's a little bit of curvature in the apical 1/3. And notice how this file moved right around that curvature and left that foramen spatially where it was physiologically before the procedure started. Notice all the lateral canals that can be potentially cleaned and filled when we have the shape. Okay, there's a lot of emerging science that is already been accepted for publication in peer-reviewed journals. This is one of them. This is done out of Nova Southeastern in Florida, and Sergio Cutler, Professor Cutler, was the researcher, clinician, and you can see that he, in this particular instance, has decornated or removed the distal root, and what we are looking at specifically is the MB and ML system. This is a mechanical study only, and what this means is Sergio and his team is very interested to look at the centering ability of WaveOne instruments and how well they actually follow the physiologic anatomy. Further, they want to know if the residual final shapes are respectful to the external root surfaces. They'd like to know how much maximum dentin is left on that furcal side concavity. So red is before, and of course green is after shaping. And in the upper left image, you can see how the original canal pathways are perfectly included in the WaveOne shapes. And furthermore, you can see that there's good respect for the remaining dentin on the furcal side. Notice those shapes are pretty much centered between the mesial and distal dimensions of the root. As an aside, you can brush with reciprocating WaveOne files. And I'm mentioning that because this is a good moment to bring this to your attention. If you want to move those canals even further away from furcal danger, and if you want to make sure that you maximize remaining dentin, certainly WaveOne files can be used with a brushing motion to address canals that have cross sections that are eccentric. So when we have eccentricities off the rounder parts of canals like fins, it's very useful to brush into those anatomical spaces to make more metal dentin contact and give us a little fuller shape, a little better shape that's conducive to exchanging reagents. Well, another study that's been accepted for publication is the study by Professor Pierre Mauchetou out of Paris 7. And in this study, it's very fascinating what was done. Now, this was done in an S block. So this is a MyFair S block, and the reason the S block is quite useful is every single canal has the same length, every single canal has the same working width, and every single canal has the same curvatures and recurvatures. Now this is important because when you're assessing instruments and you're comparing shapes of, say, one file system compared to another file system, when you work in natural teeth, you can learn a lot, but it's always hard to do the head-to-head comparison. So this is a model that brings quite a bit of challenge. It's interesting and it allows us to compare very, very accurately one mechanical system to another. So this is what Pierre did. Pierre sat down and showed 30 students, 30 second-year students, not endodontic residents, but second-year general dental students. 30 of them were shown a 5-minute video clip on how to prepare the canal, this particular S block. Then Professor Mauchetou demonstrated to his students how to shape this canal, and then he gave each student a plastic block, and they had never ever used WaveOne ever in their life, and he had them do what they saw in the video and what he demonstrated in his clinical demonstration. Let's look at what the students were able to do. Well, he got 30 blocks that look more or less just like this. If you look at the original pathway And then if you look at the WaveOne shape superimposed and registered over the original pathway, this is fascinating. Notice how the WaveOne shaping system removes virtually equal amounts of dentin on the north and south side of the canal. I'm saying north and south because in a plastic block we don't use terms like superior or inferior or buccal or lingual. But if you look at the original pathway from 0 to 1 and look at the amount of material cut on the north side and the south side, you will be hard-pressed to find any mechanical system on planet Earth that ever cuts on the inside of the curve. And notice between D0, D1, D2, D3, you're getting wonderful cutting and elimination and carving of dentin on the inside of the curve around the second bend. So this is pretty exciting. There's been other work that's already been published, and you can go to the Journal of Endodontics and you can notice the work by Gambarini. Gambarini compared cyclic fatigue when the instrument was rotated with continuous rotation to failure versus using a reciprocating motion. This was before WaveOne came to market. So what was used was the ProTaper 2508 file. So ProTaper wasn't designed to be used in reciprocation, but Gambarini from Rome, Italy, he used the ProTaper to compare that in 82 seconds, if you rotated it continuously, it failed, it broke, it fractured, it separated. When he took the same size of instrument, another 2508, he could use it in a reciprocation motion, and with the motions we've talked about, where it's 150-30, the net is 120, and 3 engaging and disengaging cutting cycles is 1 circle, he showed that these instruments lasted over 4 times longer, or 336 seconds, before the instruments failed. So right off the bat, you can see this is extremely safe. I mention this because in my lecturing around the world, I still run into countless dentists who are reticent to embrace Rotary because they have had an upset or they're worried about the event of a broken instrument. So certainly people that have had some concerns with broken instruments certainly could look at reciprocation as a marvelous way to mechanically prepare canals efficiently, safely, and, I might add, very centered. He showed us in the Journal of Endodontics that if you used 4 ProTaper files, because the F2 ProTaper is a 2508 and the WaveOne red band on the handle, it's a 2508. So we wanted to compare F2 to F2, and on our primary reciprocation file, you can see it took 42 seconds to shape a canal, whereas using 4 continuously rotating instruments, it took 113 seconds. Now, this is talking to and speaking to efficiency, and they did not count the time it took to change the instruments. So what is referred to more and more in peer-reviewed articles, so I must explain it to my audience today, is what is referred to as global shaping time or global efficiency. So presumably when you're using a sequence of instruments, there's the changing of the instruments, and then between instruments there's the irrigation, the recapitulation, and the re-irrigating. Well, with WaveOne, you go in 3 or 4 millimeters and then haul out the instrument, take it out, inspect the flutes, clean the blades, irrigate, recap, irrigate. So we're still irrigating and recapping and re-irrigating using WaveOne, but we're using 1 file instead of 4, and that's where the time is saved, and that's the global efficiency we speak of. Okay, we've looked at WaveOne in terms of its design, its metal, and its movement. We've talked a little bit more about some of its interesting attributes. We've looked at a clinical case, and I've shown you a post-op. I'd like to show you a few other cases that are emerging from around the world, done by different friends of mine. You need to look at this film by Willie Pertot, and appreciate this is, you know, it's easy to look at good endodontics and just say, yeah, another great case, but appreciate that all three of these systems were shaped with a single file, and one instrument shaped the entire molar. And notice that Willie's using good fluid activation with the endo activator, because off that MB in the apical 1/3 is another system, and it has its own separate apical portal of exit. Look at how it's recurving. And that DB is a thing of beauty, isn't it? I mean, to move down through multiplanar curvature and leave that foramen right where it was spatially before Willie ever entered the tooth, that's the sine qua non of canal preparation excellence. Yossi, up in Canada, he's spending his long winters working on his shaping game, and you can see that this tooth has been provisionalized and the post has been placed in the distal and stubbed into the mesials. But notice again the WaveOne shapes and getting that recurvature off that distal root in the apical 1/3. Very, very interesting stuff. Julian Weber, a marvelous clinician, lectures internationally extensively, but this maxillary molar was prepared, all four of its canals, with a 4008. So sometimes with younger patients with larger working widths, with a little bit of experience, you might look at a particular tooth radiographically, then when you open the tooth and visualize the chamber floor and look at the diameter of the orifices, you might realize then after glide path management that you could go right to your 4008 and not even use the 2508. But notice that MB root. If you draw a tangential line to the apical 1/3 relative to a tangential line in the coronal 1/3, those lines intersect at almost a 90-degree angle. Very, very thrilling to know you can safely mechanically use a different movement, a reciprocatory movement, and get these kinds of shapes. So Sergio Cutler, we talked about him earlier, and I showed his research, but again, look at those mesial systems and getting that little tight recurvature, and then there's some anastomosing. Beautiful shapes, very respectful to the external anatomy. And Pierre Mauchetou, we looked at some of his research, and you can see on this second molar, one instrument, three systems, nice flowing shapes, following the internal anatomy beautifully. Rigoberto, a really up-and-coming, fine clinician out of Mexico, and he is doing some beautiful cases, and he is using the WaveOne system, and here's a 2508 single file technique in this first molar. Beautiful shapes, flowing shapes around curvature, picking up the anatomy. Listen, I'm saying this over and over, and some of you are hearing me and others, you're not quite getting it, and I have a twinkle in my eyes, so please be kind to me when you see me next. The anatomy that I'm talking about has a much greater chance to be addressed when we have a full deep shape. And it's the deep shape that allows us to use the endo activator, like Rigoberto does, and move and displace reagent from the body of the canal out into the lateral anatomy. And shaping shortens the length of the lateral canals and gives us a greater opportunity to clean the contents of that system out. Okay, back to Yossi. He lobbied hard, so I put in one more of his cases. But if you have an interesting case and you're hearing this segment, please feel free to send your cases to me by email, and I will include them happily in my lectures and publishing assignments. But look at the MB1 and MB2 in getting the recurvature in that mesial systems, and notice the anastomosing going around the curve in the distal buccal, and of course picking up significant anatomy in the palatal root. And John West, many of you know him, he's probably one of the biggest advocates on ProTaper on the earth, but he's enjoying WaveOne, and he's finding indications to use it, and in this instance, look at how clean, tight, and conservative and flowing those shapes are right to the terminus. Model success, success leaves clues. Okay, WaveOne is a system-based technique. It means it has corresponding products that match the files. So you have correspondingly sized paper points, gutta-percha master cones, carrier-based obturators, and of course the new gutta-core obturation Carrier-free materials are also available and sized to fit the WaveOne shapes. Let's come back to rotation versus reciprocation, because many people want to know, since I helped co-invent ProTaper, and I just told you earlier in this show I've helped co-invent reciprocation, sometimes people want to know, well, what does Cliff Ruddle do when no one's looking? Certainly ProTaper is the #1 continuous rotation file in the world. It's taught in over 960 dental schools to undergraduates. It's used by more North American endodontists and general dentists alike than any other file system, and it's clearly, as said before, the #1 mechanical method in the world today to shape canals. Reciprocation, as I said early, everything old is new again. Reciprocation is an old idea, but it's been reinvented and improved through design, through metallurgy, and through movement. And I want to say this again and again. The movement is unequal. So you're making a much larger engagement angle and a very short disengaging angle. This means the file never over-engages. And when the file is engaging, the counterclockwise engaging angle is always about 80% of the elastic limit of the file. This should be wonderful news. Sitting on this slide forever and hearing me talk, you should have picked that up, and what you should have picked up is the engaging angle is 80% of the elastic limit of the file, which means safe, safe, and safe. So who should be thinking about using WaveOne? Who could be a candidate? What dentist out there that's listening to this might want to change? Let's go through these quickly, but yet spend just a little bit of time so you can totally appreciate the point I want to make. Well, remember, I'm a teacher, and I come before about 10,000 dentists a year physically. We have around 11 or 12,000 people that I see on my website per day, and we have different ways that we can reach people through publishing and things like that. But in meeting people personally, regardless of the country they're in, I'm seeing many, many colleagues in workshops, and they're using a lot of stainless steel files. And I'm not talking glide path management here. I'm talking to shape canals that are already secured with 10s and maybe 15 hand files, or maybe even 3 mechanical path files. But if you're using a lot of stainless steel files, a lot means 2, 3, or 4, you're working too hard, and you're not using the appropriate metals to work as safely as you otherwise could. Well, whether you're spinning instruments currently or even using one of the existing equal bidirectional systems, breakage is an issue. And it certainly is, because I get the emails and I get the conversations. I go into schools every year, maybe 35 postgraduate endo schools in North America alone, and you talk to the kids. These are residents, and breakage is an issue. And when you get pretty good at something, it begins to fall off and become less of an event, but still it happens enough to some people that WaveOne would be a perfect solution to be safer when you're shaping canals if you have any concerns at all about breaking instruments. Ledges, transportations, I'll deal with those together, but these are iatrogenic issues. They happen because of using stiff instruments, instruments that aren't flexible enough to follow the original glide path. And if we begin to internally transport, that's a ledge, or if we do it on the external root surface, that's a problem, and it would lead to wet canals, bloody canals, postoperative problems, exacerbations, needless surgeries, and countless extractions. So again, through metallurgy, through movement, and through design, we can make the canal preparation event much more safe when we have the design, the movement, and the metals. Well, a lot of you are using metals that are appropriate, like nickel titanium. You might even be using M-wire or some other super metal, like twisted file, or some of these other emerging metals. High flex is an example. But you might be using 4, 5, 6 instruments to get the shape. That's too time-consuming, in my opinion. It's unnecessary, and it's a needless complication to a non-existent problem. So that's another reason you could be a good candidate to try a single file technique? Well, a lot of you have heard lectures like me, and you've decided, because every file has its indications and its contraindications, every file system has its strengths and its weaknesses. So some clinicians try to match and mirror, if you will. They try to grab a couple files from this system and then maybe a couple more files from another system and then finish with even another system's file or files. And those hybrid techniques are convoluted, and I think they're very risky. You got to remember, when you're using different systems, you're using files that have different tapers, different D0 diameters, different rake angles, cutting angles, helical angles, different cross sections. How can you master the feel of an instrument if you're changing, even within the same canal you're shaping, to multiple different files? I've never really understood hybrid techniques. Well, this would be a reason, if you're using too many instruments and from different systems, to consider WaveOne. Finally, as a teacher, one of the most common things you hear when people come to my Santa Barbara seminars is, well, how do you find an MB2? How do you get through a calcified canal? How do you shape around a curve? How do you do warm gutta percha? How do you use the endoactivator? What about disinfection, Cliff? Blah, blah, blah. But one of the most important things I hear is, how can I be more efficient? Cliff, I think I'm spending inordinate amounts of time shaping canals. Well, I've just told you that virtually any secured canal can be shaped in less than a minute. I repeat, if you've done glide path management and you have a smooth, reproducible glide path that's been expanded to the size of a loose tin file, then you are about a minute away from having that canal optimally shaped. If I'm wrong, a minute and a half. Okay, so you can see by looking at this list and looking at yourself carefully in the mirror and then reflecting honestly, would I benefit from this shaping concept? Should I take a course? Should I read an article? And I'm very excited to be posting a WaveOne article in January in the Dentistry Today 2012 edition. And obviously that'll be on my website as well. So even if you're listening to this segment some months later, you can go to the website and for free download the article, and it'll go into everything I've just said, plus quite a bit more. Okay, to conclude this segment on canal preparation utilizing reciprocation featuring the WaveOne single file technique, I want to leave you with, never before in the history of endodontics have we been able to do so much so completely with such precision. WaveOne represents another significant breakthrough in canal preparation. It fulfills the three tenets of canal preparation, where we emphasize safety, efficiency, and simplicity. Thank you for your time.